So the last time we were working here, we talked about a bunch of factoring types. So do you remember the names of your factoring styles? So I'm going to give you a second to think about them. Okay, did you get them all thought about? Okay. Over and over again till you graduate. What are the styles of factoring? GCF is one of them. So the takeout, something common, right? What else do you have? What? We got GCF is a style. Difference of squares. When you do those, what's always important about the signs?
Minus.
Plus, minus. One group would have a plus, one would have a minus. Okay, what's another style of factoring? Complex trinomial. And then, how do you always start that one? How do you start a complex trinomial? You figure out the Fla number and go from there, right? And you get the partners. Okay, complex. You got to do a bunch of stuff with complex. You got to get that Fla number. You got to get those partners. And we're missing one kind. Simple trinomial. So a simple trinomial is when there's just a 1, x squared, x, and a number. So in a simple trinomial, it has to do what and what again? Has to multiply to that and add to that. Okay? So you have, that's your 4 styles. Over and over again, recognizing them and recognizing the strategies. Okay? Again, this basis, these 4 things, going to over and over in grade 11, gets you through your grade 12 as well. Okay? Okay, so these ones that we have, what style? That's always your first question. Just don't answer it right now. Just think, what style is it? Okay, what did we think? Which 4 styles is it? It's not a difference of squares. It is a GCF. Okay? Lots of people get tricked with the difference of squares. So it's not a difference of squares because of the m. It's not squareable for me, okay? So what is the common thing that you can take out of both of the units? M. M bracket. M bracket what and what? M times what makes m squared? M times what? Okay, so unlike last time, there's an equals 0. So this is the only thing I've changed from last time we reviewed. So now there's an equals 0. Do you understand right now that I have 2 things multiplying to make 0? This is something and this is something. There's 2 things that are multiplying to make 0. So we're going to alternate. If I want this item to be 0, m would have to be what? 0. And if I want the second item to be 0, m would have to be positive 9. Because 9, subtracting that 9 in that bracket causes a 0. Difference of, what style is it? Sometimes my brain is one step ahead of my mouth. Okay, so great job answering it as a difference of squares. You got it. Okay, so that means 2 brackets. What times what makes the x squared? So that's the first times the first. The last times the last needs to make 64. How do you make a negative number?
Negative and positive.
You need a negative and a positive. And there's an equal 0 again. So this has 2 items getting multiplied again. There's this times this. So if I want the first item to be 0, first multiplier, x would have to be a -8. To make the second item 0, second multiplier going to be 0, x would have to be +8. Do you understand if you had had yours flip-flopped of mine? It's still good, right? Okay, I'm going to let you answer this question. What style is the third one? This one is a simple trinomial. So x, x. That makes my x squared. And then we said we wanted to do something and something. We're going to think probably first, what are the multiples of 20? And then once I think about my multiples of 20, I need those 2 numbers to add to -1. So can you think of some set that multiplies to 20? 5 times 4, and I'm trying to get a -1 out of them. Once you write them down, do your check. Yeah, does that multiply to -20? Yep. Does it add to -1? So again, you have 2 multipliers. So the first unit, the first multiplier, if you want it to be 0, x would have to be 5. And this one, x would be -4. One more question. So this one is called a complex trinomial. So we had just said, let's do a FLA number to start it out. Does anybody know 5 times 12? 60. So this is -60. Okay, because of the -5, 12 and -5. 1 times 60, 2 times 30, 3 times 20, 4 times 15, 5 times 12, and 6 times 10. So 60 has all those sets that we could possibly use. What do you know about the signs of our numbers right now? I need to make a -60. So I'm going to be using 1 as a plus number and 1 as a minus number. I know that. Okay, do you have a set in there that can produce a 28? -2 and +30. Multiply to -60, check. Add to 28. Okay, now we're going to make our F list. How can you get 12x squared? 1x, 12x. 2x, 6x. 3x, 4x. how can you make a 5? 1 times 5. So partners time, I need to make a 2 and a 30 when I do this. Do you see your grouping partners to make a 2 and a 30? Two and 30. Do you see my partners that I'm making? That's the puzzle part.
Marcy,
Yeah.
does the negative ever
On the next step.
lie on
Yeah, on the next step, we're going to make sure we get it in there. But on this one, I'm not worried. Okay, so this is the partnership setup. So I'm going to draw those arcs. There's my outside. There's my inside. Remember, it's still foiling backwards, really, right? It's undoing our foil. We're going backwards. So I'm going to write 2x and 6x because the first times the first of my foil, I'm already completed. 12x squared. Okay, so the outside is now a partnership. So the 2x is with a 1, and I said I wanted that to be negative 2x. So that arc is negative 2x. And then the 6x I partnered with a 5, and I wanted that to be a positive 30x. So did you see where I am putting the negatives now? Okay, this is a little bit different. So how did I make this 0? I just did opposite, right? A positive 5. So how do I make this be 0? If you don't remember the shortcut, this is all you're doing. I want 2x plus 5 to equal 0. So what do you do? How do you solve that with algebra? What do you move?
Move 5 to the other side.
You would minus 5, and you would
Divide both by 2.
divide by 2. If you forget, that's all we're doing. We're just algebraing. And I shortcut it in the fact that it's always going to be opposite divide. That's all I think about, opposite divide. So if you thought opposite divide on this one, boom, what would your answer be?
1 over 6.
Positive 1 over 6. So that always added one extra layer to your factoring. So this would be called solving.